Alright, so for today we are going to cover our last section in Unit 2. So we're going to start with our warm-up, which is to graph an inequality, just a single inequality. So for me this says Unit 2, warm-up day number 7. Yours might say day 6. It's the same warm-up. So to graph our inequality, the first thing we need to do is get this in the normal form that we're used to seeing for graphing equations. So even though this is an inequality, it's going to get graphed just like an equation does. So we're looking for our form to be y equals mx plus b. But instead of an equal sign, we're going to have an inequality symbol. But we still want that form, which means we need to get y by itself. So we've done this a lot lately, and we know that if we want to get y by itself, the first thing we have to do is move this x to the other side. So in order to move a positive 2x, I'm going to subtract 2x. Make sure that you subtract 2x from the other side of the inequality. So your inequality symbol is right here, so those are your two sides. So whatever I do on one side, I must also do on the other. I will never, ever, ever do the same thing twice on one side. It's always once on each side. So then, when I do that, on the left side, those two x's are going to cancel, and I am left with just a negative 3y. Make sure that you don't lose this negative, that's important. Then I'm going to bring down my symbol, which is less than or equal to. And then we've talked about this before as well. We want to put our x term first. So that 2x is negative, so we have negative 2x, and my 6 is positive, so I have plus 6. Now my y isn't quite by itself, but it's almost there. I still need to get rid of the negative 3 that's in front of that y, and I know that in order to do that, I'm going to divide by negative 3, which means I'm going to divide every single thing in my equation by negative 3. So instead of just doing this entire side divided by negative 3, I know I'm going to need to simplify, so I actually want to do it to each thing. So on the left side, those negative 3's cancel out. They just become a positive 1, which leaves us with y. And here's something we need to be careful of that we forget all the time. When we are dealing with inequalities, we have to remember that if we divide by a negative number, then that's going to flip my inequality symbol around. And we talked about this when we did our absolute value inequalities. So we've got to make sure that we remember that. So we divided by a negative 3, which means this is now going to be greater than or equal to. And then negative 2 over negative 3, well, I know a negative divided by a negative is a positive. And then 2 over 3 doesn't simplify, so that's just going to be a positive 2 over 3 with my x behind it. And then positive 6 divided by negative 3 is a negative 2. Okay, now this is actually ready to be graphed. So I'm going to start with my y-intercept, which I know is the constant. So my y-intercept is given to me by this number. But remember, it's actually a point on a graph, so I'm going to write it as a coordinate point. So the y-intercept will always be 0, comma something, and that something in this case is negative 2. So I'm going to start on my graph at 0, negative 2, and I need to be careful on this graph because I can see that since this is negative 10, that means these lines are counting by 2's. So I want to make sure that I put that y-intercept in the correct place. So 0, negative 2 is actually going to be right here. Now I want to count my slope. Now my slope is going to be positive 2 over 3. So remember we said that the bottom number is always to the right. The top number is either up or down depending on whether it's positive or negative. So since this is a positive 2, that's up 2, and then right 3. Now, when I go to count my slope, I know that the y-axis is counting by 2. So this would be 2, 4, 6, 8, and then 10. What about my x-axis? Well, my x-axis is doing the same thing. This would be 2, 4, 6, 8, and then 10. So because both the x and the y-axis are counting by the same thing, then I can really just count my slope as counting these lines. So basically, I'm going to count up 2 lines and then right 3 lines and put another point. So I have up 1, 2, right 1, 2, 3. Then I have up 2, right 3, up 2, right 3. Now I want to go backwards the other way, so I'm going to go down 2, left 3, down 2, left 3, and down 2, left 3. So there are my points. Now, I know that I need to connect those points, but when I go to graph an inequality, I need to make sure that I remember whether I'm going to connect them using a solid or a dotted line, and that is based on this symbol right here. So not whether it's greater than or less than, but does it have that equal to bar under it or not? So we're going to write this down. If we have either less than or equal to, or greater than or equal to, then that's going to be a solid line, just like it would be a solid dot on a number line. If we have a less than without the equal to, or we have a greater than without the equal to, then it's going to be a dotted line, or sometimes we call it a dashed line. Same thing, I don't really care which term you use. So since we have the equal to bar under it, that means we're going to connect these dots with a solid line. If it was not equal to, then I would do a dashed or dotted line like this. Not very good, but all right, but ours is equal to, so we're going to connect with a solid line. All right, then the last thing we have to do for an inequality that we do not have to do for an equation is we have to shade one side of the line or the other. And it's important to know which side to shade. So the way that I have always looked at this is I'm going to shade either above or below that line. And since I'm talking about going either up or down, well, up, we know y is positive. Down, we know that y is negative. So we're always looking at the y. So since we're looking at y, we're trying to determine, is y going to be greater than or less than my line? So this represents my line right here. The question is, do we want the y values that are bigger or smaller than that line? So according to that symbol, we want y values that are bigger than that line. And y values that are bigger go up. Therefore, I am going to shade everything above that line. And so that's how we would graph the inequality. And normally I'd shade that in a little bit better, but we'll save some time. We can color later. All right, so that's how we graph a single inequality. Now what we're going to be doing today is we're going to be graphing systems of inequalities, which basically just means we need to graph two lines on the same axis and shade twice. And then what we're going to be looking for is where they overlap. So for this first problem in the notes, it says, what is the solution to the system of inequalities? So we're going to do the same thing we did on the warm-up, but we're going to do it for each one of these equations. And I'm going to color code them so that we know which one is which. So the first thing we want to do is we want to solve each inequality for y. So this is step one. That's important. We want to get each one of those to have y by itself. So we want that y equals mx plus b form. But we're not going to have an equals. We're going to have an inequality symbol. So once I have each one of those with the y by itself, so we're going to solve for y, then we're going to graph those boundary lines. So that means we're going to do our y-intercept and our slope. We're going to plot those points, and then we're going to connect our points with either a solid or a dotted line. So notice in step 2, it says we're going to use a solid line for the ones that have an equal to bar. We're going to use a dotted line for the ones that do not have the equal to bar. Once we have the two lines graphed, then we're going to have to shade. So we're going to shade on the appropriate side of each boundary line. So in the first one, we're going to look at, are those y values bigger or smaller? Would I shade above or below that line? Then for the second one, we're going to do the same thing. Do we want the y values that are bigger or smaller? And so do we shade above or below that line? And then this is important. The overlap is the solution to the system. So whichever section you would have to shade twice is going to be your answer. Now we can always check our answers by step 4. So we're going to check to see if we're correct by picking a point in the overlapping region, and we're going to plug it into our 2 original inequalities and make sure that it works. So let's go ahead and go through these steps with this first set of inequalities. So we're going to take that first one, 2x minus y is greater than or equal to -3, and I'm going to go ahead and rewrite it down here where I have a little more room to work. So we have 2x minus y greater than or equal to -3. Okay, so let's work on getting y by itself here. So I know that to get y by itself, the first thing I need to do is get rid of this x. Therefore, I am going to subtract that 2x to cancel it out. Make sure that you also do it on the other side of the inequality. We know that on the left side, those 2x's are going to cancel, and we're left with a negative y. Again, don't lose that negative. It's important. We'll deal with it later. We're going to bring down our inequality symbol. We're not going to change it because we didn't divide by a negative. That's the only time we're going to flip that thing around. And then we're going to write our x term first. So 2x is negative 2x. And then 3 is also negative, so -3. Now we still have to get that y by itself. It's almost there, but not quite. We need to remember that that negative in front of the y is really a -1. Therefore, we need to divide by a -1. And we're going to divide every single number by a -1. If I don't have a number in front of my variable, that means it's a 1. So if I didn't have this 2 here, then I would have to understand that that meant that was a 1, and I'm still having to divide that. But we have a number, so we're good. So then on the left, -1 divided by -1 is a +1, so that's just y. And then I divided by a negative, which means I have to flip that symbol around the other way. So instead of greater than or equal to, it's now less than or equal to. Then we have -2x divided by -1 is a +2x. And then -3 divided by -1 is a +1. So now we're ready to go ahead and graph that line. So we're going to graph that, then we'll come back and we'll go ahead and do the second line, but I want to finish this one first. So I know that for this line, my y-intercept is going to be 0, 1, because remember, this is always my y-intercept. My slope is always the number in front of x, which is 2. Now to count my slope, I need it as a fraction, so I put it over 1. Now I know that once I graph my y-intercept, since that 2 is positive, it will go up, and our 1 is always to the right. So we plot our y-intercept first, and this one, the graph is also counting weird, so pay attention. This is 2 way up here, which means that this has to be 1. So each one of these lines is only counting by a half. Same thing on the x-axis. Since this is 2, that means this would be 1. So we have to really watch for those things on these graphs that they give us, because they don't always put those nice normal graphs that we're used to. So always pay attention to where the numbers are and what each one is counting by. Because if you get your y-intercept in the wrong place, then you've got the wrong line. So our y-intercept needs to be at +1 on the y-axis, which is actually here. And then, because we're counting by half, both horizontally and vertically, I can really just count lines. So I can say I'm going to go up 2 lines, right 1 line. Then up 2, right 1, up 2, right 1. Then I run out of room, so I go down to left 1 and over and over. So this gives us all the points on our line. Now, what do we need to connect it with? Well, we do have our equal to bar, which means we want to do a solid line. So this is going to give me a solid line. So I'm going to connect those. and we're going to come back and look at the shading when we're done. All right, so we're done with that first one. Let's take a look at our second line. So the second line is going to be this second inequality right here. So we're going to rewrite that one. So we have y is greater than or equal to negative 1/2 x plus 1. Now the nice thing about this one is y is already by itself, so I don't have to change this one. I can just graph it the way it is. So I have the y-intercept is going to be at 0, 1, because remember, this is my y-intercept. And my slope, again, is always in front of the x, which this time is a negative 1/2. Now, because that 1 is negative, that means this is now going to go down, and the 2 on the bottom, well, the bottom is always to the right. So we graph this, and we know that our y-intercept is at 0, 1. That's the same place that our other y-intercept was, and that's okay. But our slopes are different, so these aren't going to be the same line, but they are going to cross on the y-axis. So from that point, I'm going to count down 1, right 2, and then I'm going to do that over and over and over. Then I'm going to go backwards. I'm going to go up 1, left 2. All right, so there are all the points on that line. And I do want to do my points all the way across because remember, we're going to have to shade. So we need to have this graph cut up into complete sections. So we need our lines to go all the way across the graph as far as we can. So now, how do we connect this one? Well, this one also has the equal to bar. So because it has this equal to bar, that means we are also going to use a solid line for this one. So we're going to connect those with a nice normal solid line. All right, now we have both of them graphed. We want to look at shading. So let's start with our pink line. So once we get it to where the y is by itself, we want to look at, is y bigger or smaller than our line? Our line is represented by 2x plus 1, and that tells us that y is smaller. So that means we are going to shade down. So for the pink line, we're going to shade down. So I'm going to wait, and I'm only going to shade one section of my graph. So we notice that our two lines have split our graph up into 4 sections. Only one of those is going to be our solution. So I don't want to have all kinds of crazy shading on my graph. I want to just have the final answer shaded. So what I'm going to do is just kind of put some arrows on here to help me remember. So if I need to shade down from that line, then that means that I would go down from here. Okay, so that means this whole thing would be shaded. So if we just had that pink line, all of this would be shaded. But we know that not both of those sections can be our solution. Only one can. So I just want to put those arrows to tell me, okay, it's going to either be this section or this section. Now let's use our blue line to figure out which one. Okay, so our blue line, we want to look at, well, this one already had y by itself, so this tells me that y needs to be bigger than our line, which means for the blue line, we're going to shade up. So this tells me shade up from that line. So that's going to be up. Okay, so for the pink one, we knew shading below the pink line meant it was either going to be this section or this section. So we know that these two are out. Nope and nope. Then for our blue line, we're supposed to shade up. Well, we already know that it can't be this one. We ruled that one out, which means it's got to be this one. So that's going to be our overlapping section. So we would shade below the pink line, but above the blue line, And the only place that satisfies both of those is going to be this section. So this is the answer to our system, is this section. So that's the only one that I'm going to shade. Now, we want to test a point to make sure that our answer is correct. And so this is how we can tell if our shading is correct. So we're going to pick any point we can in that section. Now, if that section includes 0, 0, I want to use that because that makes my math easy. Unfortunately, this doesn't. So I'm going to pick any point in that shaded section, and I like to use points where the x and y value are the same. That way I don't have to worry about getting them mixed up. So I'm going to say, let's try 2, 2, right there. So if I use the point 2, 2, I'm going to test it in both of those original inequalities. So I have in this first one, that would be 2 times x, which is 2, minus y, which is 2, because remember, we're testing the point 2, 2. And then that's supposed to be greater than or equal to -3. So we want to see if that's true. Well, 2 times 2 is 4. Then we have minus 2. Then 4 minus 2 is 1. And is 1 greater than or equal to -3? Yes, it is. So that point works for our first inequality. Let's test it in the second inequality. So if we go back to our original inequality, so y, which we're going to say is 2, is supposed to be greater than or equal to -1/2 times x, which is 2, and then plus 1. So let's see if this is true. So -1/2 times 2 would be a -1, and then we have plus 1. So then -1 plus 1 is 0, and 2 is definitely greater than or equal to 0. So that one works as well. So because it worked in both of our original inequalities, that means that that answer is correct. We have the correct shaded region. So how can you be sure you shaded correctly? Well, what we just did. You're going to pick a point in your shaded area, and you're going to plug it into both original inequalities and make sure that it works. So that's what you want to write down here. All right, so pause it, get that written down, re-listen if you need to, and then we're going to move on to our next problem. All right, so this is our only other problem for this particular set of notes, and it is a word problem. So we need to be able to translate these word problems into equations or inequalities, and then we can solve those using a graph. So your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. So at least means we want to raise $30,000 or more. More would be fine, but we do not want to raise less because we want to have enough money for these kids. So it says tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? Okay, so we have two kinds of seats. That means we need two variables. So you could use B and O for balcony and orchestra. I would probably caution against using O, though, because it's going to look like a 0. So I'm going to default to X and Y again. So X is going to be balcony, and Y is going to be orchestra. But what? Are we finding the cost of them or how many? So it says how many of each type of seat must they sell? So our variables stand for how many. So the number of balcony seats and then Y is going to be the number of orchestra seats. Now remember, we are not setting up equations, we're setting up inequalities. And we know that because we see at least, which means it can be that or more. So let's talk about how this is going to happen. Well, we know that balcony seats are $20 each. we know that orchestra seats, oops, forgot my R, are $30 each. We need to raise at least, that's important, at least $30,000. Okay, and then the other thing we see is that it says the center has 500 orchestra seats. It doesn't say anything about how many balcony seats there are, but we know that it only has 500 orchestra seats. So that tells me that you cannot sell more than 500 orchestra seats because we don't have any more than 500. So if 500 is the number they have, they can't sell more than 500 of that kind. So we can sell no more than 500 orchestra seats. So that's everything we know about this problem. So remember, no more than 500. So we can sell exactly 500 or we can sell less than 500, but we cannot sell more. Okay, so remember, balcony is X, orchestra is Y. Okay, so we're going to start with that for our first equation. So we know that we want to raise at least $30,000. That's my total. That's the smallest total I want to have. Therefore, since balcony seats cost $20 each, then that means we're going to have 20X and then plus orchestra seats are $30 each, so 30Y. And that could equal 30,000, but then the question is, do I want that to be greater than or do I want it to be less than? So which way do I want it? Well, think about what this actually represents. So this represents the amount of money that they are actually going to raise. So they're selling these seats. They're selling balcony seats at $20 each, orchestra seats at $30 each. So this expression represents how much money they will actually bring in. So we know that we want that to be more than or equal to 30,000. So we want that symbol to be that way. So 30,000 is the smallest amount we want to raise. So we need to make sure that the small end of our symbol is towards the 30,000. So there's our first inequality. Now, that means that we have used this information and we have used this information. The only information we haven't used yet is this. So it only talks about orchestra seats. It says nothing about balcony seats. So orchestra seats is our Y. So then we know that Y could be equal to 500 or it could be smaller than 500, but it cannot be more than 500. So we know that Y could be smaller than or exactly equal to 500. And so then those would be our two inequalities. So remember, Y can be smaller than 500, but it cannot be bigger than 500 because we don't have any more than 500 to sell. Now to solve this, we would want to put this on a graph. So I don't have a graph here, so I'm just going to kind of do a quick sketch of one. So if we have our graph, now I'm only putting the positive X and Y axis because this is a real world situation. We can't have a negative number of seats. So we're going to have along the bottom, I'm going to make that my balcony seats, and that's because balcony was X. And then along the Y axis, I'm going to make that orchestra seats because that was Y. Okay, so let me zoom in on this. So we need to put some numbers in here. So we know that balcony seats, well, we have no idea how high those can go, but we know that orchestra seats can only go up to 500. So I'm going to say 1, 2, 3, 4, 5. So, and we're going to make these hundreds. So this is 100, 200, and I should have left a little more room to write. 300, 400, and that would be 500. All right, so then along the bottom, again, I have no idea how many balcony seats there are. Probably a whole lot more if you think about most auditoriums. So we may actually want to make this x-axis a little bit longer. So I'm going to extend that out here. And so I'm going to have 100, 200. So I'm just going to put 1, 2, and 3 because I don't have a lot of room here. 3, 400, 500, 600, 700, 800, 900. That would be 1,000. And that would be 1,100, 1,200, and hopefully that's far enough. If not, I guess I can extend it some more. Alrighty, so let's go ahead and graph. I'm going to start with the blue one because that one is actually probably the easiest to graph. So it says that y has to be smaller than or equal to 500. So y equals 500 is right here. So that means that I'm going to have a line, a solid line, right there. And then that's going to be my y's. Now I know that y has to be smaller than that. So that means I know for sure that I'm going to be shading below that. Now we need to do our pink one to figure out where in the world we're going to have to shade our overlap. So if we take our pink equation and we want to get y by itself. So, oops, we have 20x plus 30y greater than or equal to 30,000. So then first thing we want to do, get rid of that negative 20x. Do the same thing on, 20x. Do the same thing on the other side. Those are gone. That leaves me with a positive 30y greater than or equal to negative 20x plus 30. I did not give myself much room. Let me move that over. So 30y greater than or equal to negative 20x plus 30,000. All right, be careful with your zeros. Make sure you bring down the right number of zeros. Then we know we need to divide by 30, and so we're going to divide every single number by 30. And then we're going to simplify. So we're going to have y greater than or equal to, well, I know that negative 20 over 30 is going to be a negative, and then 20 and 30 can both be divided by 10, so that really just becomes 2/3. So negative 2/3 x, and then plus 30,000 divided by 30 is 1,000. So that tells me that on my y-intercept, I actually need to start at 1,000. Well, that's a problem because I only went up to 500. So I would need to continue this. And this is not a pretty graph, so you'll have better graphs to use. So we're going to say 1,000 is going to be up here. And then we're going to have to go down 2, right 3. So then from 1,000, I'm going to go down 2,000, right 3, or sorry, not 2,000. What am I thinking? So I'm going to go down 200, right 300. Down 200, right 300. And then if we had an actual graph that we could count a little bit better on, I would see that this is going to cross my y-axis at, it looks like about 1,500, so over here. Oh, these should be pink. And then it is also equal to, so I'm going to have my line here, so I'd have all those little dots that I would connect. And then, where do I shade for this? Well, this tells me that y is bigger than, so we would have to shade up. So from my line, well, obviously I'm not going to shade there, but I can shade there. So my overlapping section would be this in here. So my orchestra seats would be less than 500, and then my balcony seats could be any of these X values in here. Alrighty, so I apologize for the graph. Hopefully you were able to follow all of that. So the questions are, what do points in the overlap represent? So if I look at my overlapping section, well, those represent the number of balcony seats and orchestra seats that we could sell, but not just the number that we could sell, but the number of seats, the combination of seat types that need to be sold to raise 30,000 or more. So it's all the combinations of balcony seats and orchestra seats that we could sell that would raise at least 30,000 or more. And then what does the intersection represent for this solution? Well, the intersection of my points is right here. That intersection is how many seats of each type we would have to sell to raise exactly $30,000. And again, if we had a proper graph, we could actually tell what those were. So on a proper graph, we would have that intersection at 700. So it would be at 7, oh, hello, that's not a pen. So your intersection would be at 750, comma, 500. So that tells us balcony seats and orchestra seats. So to raise exactly $30,000, we would have to sell all 500 orchestra seats and then 750 balcony seats to raise exactly 30,000. So anything over that 750 balcony seats, we're going to raise more money for those kids, and that's what we want. Okay, so that is it for Unit 2, LT6. So you guys are going to get going on your paper assignment and your Pearson assignment if you need to do that. And then I will see you guys next time.